My name is Peter Detender. I'm a Microsoft technical trainer from Redmond, Washington. I've been a trainer for a bit more than 14 years, but within the Microsoft role, a little bit over 5 years now. The trainings that I typically deliver are Azure architecting, developing together with DevOps, and now also moving more to AI and Copilot courses. In session 2, we'll explore the models, where the models literally refer to large language models, or LLMs, allowing you to deploy them out of Azure AI Studio. I would say let's get started. So with the first section done, you learned about Azure AI, you learned about how our Azure AI Studio can help you as a developer, as a data scientist, and really managing your AI projects out of the AI Studio. Now from here, let's move on to the more technical generative AI components, where I'm going to walk you through data models. We're going to explore them. What is a language model like? What are the different variations we have in the AI Studio? And then obviously testing them using some chat interactive functionality. Now, one of the main challenges we have is deciding what language model we need. Now, maybe for some of you, you don't even really know what large language models are. So in short, a large language model is like a trained model, typically based on public internet available data, where OpenAI, I would say, is a popular one. Now, if you were one of the early adopters of Azure AI Solutions, we offered you OpenAI Studio, where the benefit was that you got access to all possible OpenAI language models. The GPT versions, version 2, 3.5 Turbo 4, the DALL-E for image generation, the Vinci for text generation, and a few other ones. But nowadays, the world of AI is becoming broader. I would say the adoption mechanism we're using out of our Azure AI mindset is not only giving you access to the OpenAI models anymore, but also bringing in other models. So for you as a developer, bringing in that Copilot-alike scenario into your applications, one of the first challenges is what application language model do I need? Now, some of the language models will provide you different functionalities. Like again, within the OpenAI spectrum, if you want to do chat completion-alike functionality or summarizing text, for example, you're going to use a GPT language model. If you want to integrate image generation based on, again, a prompt, you're going to use the DALL-E model. Now, from there, it really depends on what kind of functionality. So simplifying it a bit, if you only want to use chat conversation functionality into your app, building your custom Copilot to, again, build up that help desk-alike scenario, the customer interaction scenario, finding travel options or whatnot, that's where your DALL-E OpenAI engine will not help you. So that's where I would say the starting point really lies. What is a large language model? It's that database, you could say, the library of information, and what kind of functionality do I want to bring in to my applications. Now, to help you a little bit with that, it's where the Azure AI Studio is going to give you different categories. Now, one of the first options here, the GPT one, is actually listed as the second one. I already talked about it, so that's that generative pre-trained model having access to that large information database, I like to describe it, based on public internet information. So if you have questions about what's the weather like in Seattle, it's going to be able to answer that question. I should try and remember that prompt later on in one of the demos, by the way. Now, again, it's not just about OpenAI anymore. So out of AI Studio, we give you integration with other scenarios. Like, for example, here Llama is mentioned. So Llama is a GPT-alike language model coming from Meta, the company behind Facebook, right? Or Phi 3 Mini is some sort of a stripped-down language model where we're now describing it as a small language model. So what's the idea? The large language model has a huge amount of information that, based on, again, your prompts, it's going to recognize the prompt, question the data that you're looking for, and it's going to provide you an answer. But maybe in your solution, you don't need access to all possible information out of that large language model. And that's, for example, what Phi 3 Mini is going to help you with, where out of Microsoft, we're creating our own language models, and that's just one example. So the starting point is deciding what language model do I need. Now, I'll show you in the demo later on First of all, which language models you can integrate inside your AI Studio, the ones from OpenAI, the ones from Llama, from Meta, I should say, and so many other ones. Next to that, you're going to deploy your model. What it means is that we have our AI service running in the backend. We have our AI Studio, the management interface. We deployed our AI hub, one or more, and within the hub, we define a project. Now, the project is not able to do anything as long as you don't deploy a model. Now, it's not 100% correct because there are other functionalities in the studio related to the project. Think about the responsible AI, think about the permissions, but talking a bit more about how can I actually start using my generative AI solutioning, that's where the model is really the next first step. So you're going to think about what model do I need? And yes, some more complex custom Copilot scenarios could be based on different models. An easy example, if you want to integrate chat completion, but you also want to allow the customer or the user to generate images, you're going to integrate the GPT model from OpenAI, and you're going to bring in DALL-E from OpenAI as well. And again, it's not just about OpenAI, but it's one of the nicer examples that I'm most familiar with. So you're going to pick the model, one or more. You're going to link them to a project, and each and every model gives you an API endpoint. Now, an API endpoint is really, I would say, as a developer, that integration. I have my prompt. I'm going to send it off to the large language model, and I'm going to rely on the natural language processing capability from that model to provide me an answer. So if you're a little bit familiar with API integration out of API management or an integration with external data resources out of an example scenario that you already have today, bringing in that generative AI capability, developing your own custom copilots, right? It's nothing really different as long as you already have that experience on how to integrate your API endpoints. So we're trying to follow a lot of, I would say, common standards. If you know how to interact with an API already today, it shouldn't be really different on how to knowing interacting with an API endpoint and connecting to your large language models deployed out of the studio. So you deploy the model, and from there, you're gonna what we call the model like really interacting. One of the easiest ways to validate, like, is this model really doing what I'm expecting within my custom copilot? That's where you're gonna use the playground. Now, I really like the word playground. Why? Because you're not really misdoing anything. It's also giving you a lot of settings parameters where you can manipulate the behavior of that playground. So in the logical flow of what does it take to actually get started with my generative AI custom copilot developing, again, you deploy the AI service, that's the starting point. You create a hub, you create a project, assuming you have the correct permissions in place. You did your responsible AI validation. The next step is deploying the model and relying on the playground to really test it. Now with that, I'm going to switch to my next demo, actually showing you what it takes to deploy a model, showing you how to select, because for some models, we're actually identifying what are the core capabilities. In this kind of scenario within your app, this model would be the more recommended one. And then from there, once we have that model deployed, I'm going to show you how to interact with it, and then closing with using the playground and testing the chat functionality. So up till now, we deployed our Azure AI Studio, we created a hub, we created a project, and we defined RBAC permissions. Well, now finally, we can shift to the actual deployment of a model. And why not maybe multiple models? So I go back into my hub, I switch to my project level, and down here, I'm going to interact with the model catalog. Now, the benefit about the model catalog is that it's really that central point where you can find all possible available large language models that you can deploy on top of your Azure AI Studio. So for each and every of the models, you can define some filters. You can define how you want to deploy them. You can filter based on fine-tuning tasks, like some of the models are maybe helping you with text classification. Some of them, like I would say the GPT ones or the Llama ones we talked about, are the ones you're going to use for chat completion. So out of this massive catalog, you can create your own filters. So from there, let's say I want to deploy GPT 3.5 Turbo. You can also use the search functionality. So let's do GPT-3.5, where it's still giving me all the different 3.5 options. I'm going to use 3.5 Turbo just as an easy example. And even without knowing anything about the model specifically, it's providing you a nice detailed description. And there's also a pointer to additional documentation about that specific model. From here, you can define fine-tuning that I'll talk about a little bit later on. Now, keep in mind that not all large language models actually allow you to do fine-tuning. It's also the reason, if you remember, in the first step of my deployment of the AI Studio and Hub, I picked Sweden Central because that's one of the regions actually offering models for fine-tuning. From here, you can actually decide on deploying this model, which means I'm going to bring in the large language model capability. I'm going to create an endpoint, and from there, I can start integrating it into my applications. It comes with a default name similar to the flavor of the large language model. And I still like to give this a little bit more of a descriptive name, where I'm following the same naming convention, where now this is my demo hub live, that's my hub and my project, GPT-3.5 Turbo deployment name. I can define the default settings here, the model version, the version of the API you could say that the model is using, which Azure services and project it belongs to, and it can also allow me to define the capacity. Now in my example here, 100,000 tokens per minute is probably way too much. So I'm going to lower this down a little bit. Now in your own environments, in short, the way an Azure subscription works with AI services is based on quota limits. So there is a certain set of quota per region, per project that you can allocate. And every now and then, if you just go next, finish, and accepting the defaults, you might run out of quota, where some of the testing out of the chat playground might not work anymore. So that's where I would recommend you, at least in a test environment. Obviously for production, the settings will be totally different. But in a test scenario, validation scenario, I would recommend you initially at first to move down that number of tokens. Like in this case, 5,000 allows me to have 30 interactions per minute. That's like firing off a new chat prompt every 2 seconds, which is probably not what I need even in my demo environment. And I'm going to deploy it. So the deployment is done. Important here is the target URI. That's what we need as AI solution developers to integrate it within my application. And we also have the key where obviously it's a little bit encrypted here on screen to make sure that not just everyone looking at the Azure portal gets eyes on the keys. Most important after running our deployment of the model is testing it out. The best way to test it is using our playground. I talked about the playground a little bit in one of the first demos, just the interface, you could say, to validate your environment. So what I can do here is firing off a prompt, asking a question, as we call it, and just asking, what can you help me with? So this is a pretty generic prompt where I'm just relying on a test, because in the end, the goal of a large language model is based on a prompt, based on a question. The input, as we will call it later on, is asking a prompt question and waiting for an accurate response. So in this case, we didn't really specify anything, but I have, I would say, the confirmation that my large language model is working. A little bit of a different test is validating something about an actual piece of information, like what is the weather like in Seattle around August. Now it's relying on public internet information, how the large language model got trained, and it's going to tell me here a nice description. In August, the weather in Seattle is generally warm, pleasant, with highlighting some of the temperature details in Fahrenheit and Celsius, and a little bit more on that. I could also ask something around who is the Prime Minister of the UK, where I'm now validating what date, you could say, what is the timeline when that model get trained. So in this case, it's not really specifying it yet. So I could ask like, up to what date did you get trained as a model? Where it's not even exposing any specific training date, but I'll try to bring in yet another example in the next second, and then hopefully it's going to tell me how that actually works. So to give you an idea, we're going to add an additional model. We deployed GPT 3.5. It's I wouldn't say outdated, but if you follow a little bit in the large language model space, you probably heard about GPT-4 and even later GPT-4o. So again, same as before, I select GPT-4 as my next large language model. And in a real life example, building your custom copilots, right? It might end up in deploying multiple models that you're going to use within the same application solution. So I'm going to deploy it same steps as before. I'm going to follow my own naming convention standards a little bit. I'm back in my chat playground, where now from here, I need to give it a little bit of time. We're now here in my chat playground. I still have my previous 3.5 large language model, where now I can switch between 3.5 and 4. So let's do the same test as before, switching to large language model type GPT-4 and asking the same question: what is the weather like in Seattle in August? And as you can see, no surprise, the answer is about the same as the previous one using the other model 3.5. Why is that? Because it's factual information. The weather is not really changing based on the date when that large language model got trained. But I'm again going to try, who is the Prime Minister in the UK? Another interesting one here is that there is a typo in my prompt, but it's not really blocking the usage. And for some interesting reason, it's still not really exposing the date. So let's try something different. Who is, let's say, is Queen Elizabeth II still the Queen in the UK? Why am I doing this? Because every now and then, based a little bit on the prompts, it's going to tell you like, well, based on my date of the training model, it's telling me like, well, as far as I know, from somewhere June 2021, for example, it was still the case. So that's what I'm trying to unlock here. But I might bring in a few examples to try something different later on. From here, I can show you how to deploy other models. So I did the same demo, deploy GPT 3.5, GPT-4, where now I can filter based on different vendors. So I talked about Meta with the Llama, large language models, and as you can see, that library is also quite extensive. So I'm going to use just the first one here in my option list. And now it's providing, again, additional documentation. This is the use case for this Llama large language model. There's some information about pricing. There's information about the tokens. And I would, again, recommend you, before you start just going out and deploying a model, really looking into the details, already nicely integrated here, but obviously maybe even looking at the original vendor source, but the deployment is exactly the same. For now, it's going to ask me a few additional questions, but the baseline is roughly the same. Just want to show you this. I'm not actually going to deploy this because I'm not really needing it in any of my future demos, but just giving you that experience that depending on the large language model you select in that catalog, the way you're going to interact with it, the way you're going to deploy it might be slightly different. But the baseline is, now you know about the model catalog and you know about the deployments. Last little piece here is starting from a different location, but technically doing the same thing. So we started with the model catalog, like give me access to that full library of Azure AI integrated, supported large language models. Where now, after running a deployment, I can also actually validate them from here. So initially we deployed Demo Hub Live GPT-3.5. Later on we deployed GPT-4, where now from here I can yet deploy another model. Where obviously this list is exactly the same as going through the catalog. Two different locations to basically end up with the same outcome, how to deploy a large language model. Let's move on with the rest of the presentation. So now we managed to deploy our models. We did some testing validation using the playground, but now we are seeing another challenge. What I'm talking about is benchmarking. So what is benchmarking? We have a lot of different models. I only picked out a handful of them in my previous demo, but in the end, we have a huge library of models to choose from. Now, as a developer, how do you know which model works best for that specific scenario you have in mind for your custom Copilot? You can go through a huge amount of testing. You can obviously do reading. You can just rely on a gut feeling if you want, but that's not always reliable. So what we can do, and it's part of the AI Studio, obviously, is running benchmarking. So what we're going to do is really validating. I have different models, and based on the use case of that large language model, how does it rank? Where we're looking at different scenarios. So there's a couple of keywords here. Accuracy means how well does that large language model interpret the prompt. I'm giving a prompt like, again, what's the weather like in Seattle? And obviously, as a user, we're assuming that it's going to provide a good answer. But imagine that it's not always providing that exact correct answer. And I'll show you some examples later on how you can actually play and manipulate. Think back about the groundness that I already talked about before. But accuracy is really how smart, you could say, is that large language model to interpret my question and providing a decent answer. Where next to that, the coherence and fluency is a little bit more towards the natural language processing aspect of it. Like, it's going to recognize the prompt, it's detecting the question, it's going to provide you an answer. But apart from like how accurate is that answer, the coherence and fluency is also checking like how fluent is this, like how close does it represent a human-alike answer. So it's not only about technically being correct, like the answer is really giving you an actual fact, like this is what the weather's like in Seattle in the month of August, why not? But then also how is the natural language processing integration giving you that answer? Does that sentence make sense? Is it like correct from a grammar perspective? So that's mainly what coherence and fluency is doing. The groundedness is where later on we're going to bring in our own data sets. Where now out of the benchmark, we're going to know and we're going to validate like what is the ranking, the number, if you want, that gets allocated to that groundedness. Where it really means like I have my custom data set, like in my travel agency example that I use later on, I'm going to bring in some flyer information, a brochure if you want, from different places in the world that my customers maybe want to visit. So when I'm asking a prompt like, what can you tell me about London? What can you tell me, like, what can I visit in London, for example? I want to make sure that all the data is not only correct accuracy, is not only presented in or described in a natural language, human-alike way, but I also want to make sure that the answer itself, the data to really provide me that answer, is as close, as accurate as possible to the data from my data set. And that's what the groundness is doing. And then overall relevance is really like based on the purpose of your solution component, like what generative AI functionality do I want to integrate, where it's going to identify based on chat conversation, GPT would be okay, the Meta Llama would be okay. But again, the DALL-E example is not going to help you for chat completion because that language model cannot help you with that. So that's where that relevance comes in. So this session is now concluded. Now, there are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.